Alright, so what we're going to look at here is called the combined gas law. The combined gas law has got its name from the fact that this law combines all three variables. You remember before when we did the other three, it was only two variables. We're going to look at three variables: pressure, temperature, and volume. So it does make it a little bit more complicated to do these problems. It takes a little bit longer. Here's the formula, which is actually listed on table T. These are your initial pressure, volume, and temperature readings, and these are the final pressure, volume, and temperature readings. Most of the time, they're asking you to solve for one of the variables that has a 2 next to it, either the final pressure, the final volume, or the final temperature. Not always, but 99% of the time. A couple of things that you have to keep in mind, and this is an extremely important point, that when you are solving any gas law, whether it's this one or involving just two variables, you have to remember this here, that temperatures must be in Kelvin. Now, how do you convert from Kelvin? To go from, degrees Celsius to Kelvin, you simply add 273. So it's relatively simple. Going from Celsius to Kelvin, you add 273. It's an important fact that you remember. For the pressure and volume, make sure the units of the initial and final are the same. So what they're saying here is that if P1 is in, let's say, kPa units, well, P2 also has to be in the same units. You can't use two different units. That would be like using temperature would be degrees Celsius here and Kelvin here. You can't. They both have to be in Kelvin. Both volumes have to be in the same units. Either they are both milliliters or they are both liters. So the units for pressure and volume should be the same on both sides, and so should temperature, obviously. If a variable remains constant, you can take it out of the equation, and you'll see this. If they give you a question where they say volume is constant, what you would do is you'd use this formula, but just cross out the v's, and you'd be left with the part of the formula that you need. Or if they said to you that temperature is constant, that means that T1 and T2 are the same. You can exclude them from the equation, and you would just have to use the top. And you'll see this as we do some practice problems. So let's take a look at our first example here, and I'm just going to set them up. I'm not going to go through because it takes forever to do these. Here's the formula at the top. So the first thing is you have to recognize that that's temperature, and let's see, it only gives us one temperature, so that would be this one here, 200 K. The pressure of a gas is increased from 200 kPa, so this is 200 kPa, that's pressure, to 305, that's 305. What is the new temperature? Now you're saying, well, wait a minute, something's missing. Yeah, notice it says constant volume. If it says constant volume, that means you do not need volume. So really what you have is you have 200 over 200, which is obviously 1, and equals 305 over T2. Okay, and then what you would do is you would cross multiply. You'd multiply these two, and you'd get T2 times 200 equals 305 times 200. You divide both sides by 200. So T2 in this essence would be 305 because these two would cancel out. And so it would be 305K. So you have to keep in mind, if something is constant, you do not use it as part of your equation. You simply just cross it out. It could be pressure, it could be volume, could be temperature. All right, the next one is if a gas at 8 atmospheres, this is also a unit of pressure, it's just a different one, is cooled from 600 to 150 K in a rigid container, what is the final pressure? Well, if you notice here, they don't give you volume, so you can assume that volume is constant. So you are going to use basically the same part of the equation that we used before. You have P1, which is 8. You have T1, which is 600. You have T2, which is 150. So now what you're looking for is P2. It turns out to be 2 atmospheres. And again, if you don't figure this out, if you can't get 2, we can go over it in class. It's not a problem. All right, now this is one way you see that nothing is constant. So we're going to go through this, and I'm going to show you how to determine which is the P's and the V's and the T's. Okay, so again, what you're going to have to remember, and you might want to write this down, this is going to be either milliliters or liters. This has to be in Kelvin. And pressure is either going to be at, oh, sorry, get back to this slide. And pressure, you can see went off. Pressure is going to be either atmospheres, or, I don't know what happened here. Pressure is going to be either atmospheres or kPa. Alright, so you have this, and usually the first numbers are the ones and the numbers at the end are twos. So that's going to be, that's volume, that's V1. This is going to be P1, and this will be T1. And the next numbers we have 2.4 liters, that's going to be V2, and that's going to be P2. So what we're looking for is T2, and it's going to end up being 159K. So go through that calculation, cross multiply, solve for what you're looking for, which is T2. And I'll give you the answer to the last one. The last one comes out to 28 liters. That is also a combined gas law problem. That's 28 liters. I think that is it. So obviously, you know, we can't spend a lot of time on this. So if you have questions on these, we can certainly go over them in class, and that would be your time to ask questions. Okay, so